Now, before we start, just a little bit about Hotovo for those that don't know. So Hotovo is a nearshore software house. For over 10 years, we've been providing software and working with Fortune 100 companies, all the way through to small SMEs. We use languages like Java, JavaScript, .NET, and a myriad of others. And we specialize in things like system integrations, mobile development, and web development as well. Now, our ethos is really that of integrity and really building those long-term relationships with you. And we do that in a number of ways. And one of the ways that we do that is through something called team augmentation. So we work alongside your existing dev teams, software development functions in order to deliver things like bespoke software, desktop applications, web applications. Now, we're also specialists in mobile development, so that's something that we can deliver for you as well as mobile solutions. And we're actually a MuleSoft solutions partner as well. So we're actually working on the Mule integration projects themselves, which is pretty exciting. So, like I say, I'm from the Hotovo office in the UK, and I've got all my colleagues here as well, joining us from the Hotovo office in Košice in Slovakia. So, what do we expect from this evening? We have 3 talks lined up for you. The first of which is with my buddy Stano. He's going to take you through a cloud agnostic view to DevOps. We have a talk from myself. I'm going to be taking you through a DevOps approach with more of an AWS spin. And then for our finale, we've got Miso Kaskak, and he's going to be taking you through Java and how that works cloud natively. So, without further ado, I'll pass you over to Stanley for our first talk of the evening. Thank you.
Thank you, Aaron. And my name is Stan, and I will be the first presenter. Ladies and gentlemen, damen und Herren, my dear Lucy, thank you for joining us at this evening time. I'm going to have a light talk about how we are doing cloud agnostic solution for our clients. First thing, what means to be cloud agnostic? There exists a couple of main providers of cloud solutions. We can talk about Amazon Web Services, Google Cloud, Microsoft Azure, and also others. Cloud agnostic for this presentation means the way to deploy a solution to any infrastructure available on the client side. So solutions should not be coupled to a concrete cloud provider. What it means to be cloud agnostic? It means to be flexible. The main problem to have a general solution is about issues of unknown. And the only way how to fight unknowns is to be flexible as much as possible. You never know where your solution will need to be deployed. It can be a single computer with RAID, pair of computers, whole data center. Will the solution depend on other systems? The solution shall be ready to grow up with new requirements. And even if you do your best, your solution will end up in totally different deployment as you originally planned. Anyway, we'll try to fight these issues of unknowns and get as much as possible flexibilities. First thing, we are doing the containerization. We have agreed that containerization is how to go. It provides several benefits like isolation and portability of your solution because of dependency isolation, efficiency, more efficient than virtual machines, those friendly, easy way to integrate into your CI/CD processes, and much more. The question is which containerization is the right one. It really depends case by case and on your content requirements. For example, the most modern way is to use Docker as a container solutions. After some time, maybe we'll switch also to pure CI images. But let's discuss a little bit about one single process-based containers. It means the container is running a single process, or to have multi-process. If you start to judge me if one process way of containerization is the only right way how to do containerization, because it's quite modern now, it's not the topic because it's the right topic I want to discuss it in this presentation. But especially as I mentioned before, the way to fight the unknowns is to be flexible. And there exist the systems that are not ready for containerization. and it may take significant effort to do it. That's the first thing. Another thing which need to be considered is about the container orchestration. So even if we have the containers, we need to orchestrate them. Maybe the first stack which you are going to consider is a container orchestrations will be about Kubernetes. I'm not saying no. It's popular and more common way how to orchestrate containers, but there is still a couple of things to consider before we choose the Kubernetes as the right one. It's about the complexity and learning curve. If we are going to deploy the Kubernetes on a premise or it will be cloud solution, the target infrastructure has only one or more nodes. It's good to know that Kubernetes is designed to run on. It's not designed to run on single node in the production, but it needs probably 3 or 5 computers, physical computers, to run in production. There's also other concerns about the local development, how to integrate Kubernetes with other runtimes, and so on. There's also other provisioning tools like the Docker Compose, Docker Swarm, and probably, yes, you can go this way. I don't want to say now. I don't want to commit myself to Docker suits, but it's subject to argument. So it's also other way how to do it. But also, such texts like the Kubernetes have issues of simplicity, issues known as absence of flexibility. Those solutions have been designed for to concrete purposes, and if we want to have flexible solutions where you have a lot of unknowns, it may be not the right way how to do it. So what about pure Linux and subscripting? Are we talking about greenfield solutions? Not completely. It's only about the greenfield solutions at the upper level of our DevOps. We have decided to use the Linux containers. Linux containers is systemd based, so it means that it provides a way how to run multiple processes within single container, which is really useful in case that you are not able to switch the application to single process. And the Linux container provides a way how to deal with it. Before we move to the DevOps tool, which is a part of these presentations, I want to close this topic on infrastructure, how we are doing it. On the top of this infrastructure, we have a DevOps tools. It's a provisioning tool. It's an ops tool. On the next level is the provisioning tool. We are using the Ansible script, but you are free to use anything what you want. There is another layer. There is the firewall based on IP tables, which is the firewall between the public interfaces and containers itself. In this container itself, we have common containers like the Nginx proxy, PostgreSQL database, application containers. And the next level, those the LXC containers. We're also considering to use the RANC as the single process containers, but now we are using the LXC containers. And the next level is about the Linux virtual machines, which is on the bottom level. We are using AWS EC2 instances. We can use OpenStack instances, bare metal computers. It all depends on the concrete client requirements. But that's the stack which we are using. Most of those things are real pure Linux, which is known for decades with uncountable possibilities of customization. You can use the full power of your firewall, uncountable features of your engines, different file system or volume managers like logical volume manager, Linux volume managers, logical volume managers. In other words, it's limitless flexibility. It increases complexity, but your Linux staff already know all those things. So bear in mind, this stack has been created and has been designed with the main focus to flexibility. I'm not saying that this is the right solution for each project, but that's the stack which has been chosen for flexibility to be able to provide the solution for our clients where we don't know where we will need to put the deployment. So as it was mentioned, we have the Linux containers and other stuff, and those stuff need to be orchestrated, but there is still missing piece of magic, and it's about the DevOps and Ops tool. When you start to develop software solutions, you start to choose different technologies. I'm talking about user interface, probably written in React, REST services written over Spring Boot or Nest.js, we will choose database relation or NoSQL database. But there is the glue needed to get all those things to work. And inside, it's the code itself. It's no manual intervention, just the code. What glue we are using for DevOps? The answer will be for some of you, nothing. Those people have some makefiles, shell scripts, provisioning tools, but there is a gap between the developers and infrastructure staff. A gap meant to be covered by DevOps activities, but what should be the result of that? We believe that it should be an ops tool, the tool between the developers and infrastructure team, development team and infrastructure team. Is this tool a provisioning tool? Probably not. The provisioning tool is for DevOps or infrastructure staff. An ops tool is the glue between the developer results and DevOps results. So it's on the top of the provisioning tool. So we have created TypeScript-based ops tool. We have created TypeScript. We have chosen the TypeScript programming language for this tool because infrastructure things take significant time from your workday. So you want to avoid unnecessary issues. So we have decided to choose the type language. There's also the question, what about Python or Go language, which is probably more known by DevOps, but it's less known by general developers. TypeScript has a lot of features for the grammar definition, and it's still scripting language. And it's the best documentation for your tool. The best documentation for your tool is the code itself. And we want to expert our infrastructure in the code. So because of this one, we have chosen to use the TypeScript as the main language. As you can see on the left side, it's the simple command line interface, which is written by developers and DevOps staff. And this the same CLI interface can be used by CI/CD processes. So first thing, which is the input to our DevOps tool, is about DevOps tool descriptor or tool descriptor. It's about the descriptor itself, the descriptor for your project. As you can see on the left side, it's about the TypeScript file. It's not a JSON. Why it's not a pure JSON and it's the TypeScript descriptor? Because it's easier to build a descriptor via programming language because of commands, configuration dependent on the current environment, variables, type checking, and all those features which is provided by are provided by the TypeScript. But at the end, this descriptor is the input to the DevOps tool. So it's saying what kind of infrastructure our project is expecting, what we are going to deploy, what will be the configuration of the proxies, and all those stuff from the descriptor is transferred into the Ansible script. It's mostly about the generation of the variables for Ansible script. It's some tweaking of the Ansible scripts, like choosing the right one based on the roles, but it's still not fully greenfield solution. It's just the tool which will create the files for provisioning and for building and stuff like that. As you can see, there's the builders, which are responsible to build the artifacts. There are provisioning, which is responsible to build up infrastructure based on the containers to configure those containers, etc. The whole tool is split up over a few things. The first, it's about a set of commands which are responsible for local development. Because usually you need to start developing on the local environment probably before you are moving to the production. The first command is just about the initialization on the init, which is responsible to create the VirtualBox images for background. It's based on the packer from the HashiCorp solutions. So it means that it will create the local Debian Linux, almost the same as the one which is running on virtual machines, e.g. on our EC2 instances. So there is minimal installation drift or minimal drift between the instances, between development instances and production one. Other command is about the dev stat, which is again just the wrapper of the around the background, on the top of the background, which is responsible to start the local environment. It's a shortcut to be able to get into the host if we need it. Stop, it's just to stop the Linux host, and destroy the instances just to free the resources. Another set of commands is about the provisioning. So we're doing the provision infrastructure. So before we can do it, there's a provision infrastructure which is responsible to initialize minimal environment needed for containers like Elixir host, the firewall, networking, stuff like that. Even it sounds crazy or difficult, it's just few Ansible scripts of tasks which are responsible to build up this Alexa host. So it's quite easy. After that, there is the provision setup command, which is responsible to set up all containers, mostly about databases, proxies, all stuff which is not changing during the development quite often. It's just time to time you need to change something like to change the database configuration, change the proxy and stuff like that, because this one is dedicated command. The other command is about the provision deploy, which is responsible for deploying of the application, the version of the application of your code to the host. The next one is about the ping, which is just a health check for running containers. You want to ensure that everything is okay. And the last one is about the provision cleaning. This command is only for development purposes and is responsible to clean up the databases and rest of the state of the software solution in the initial stage, for testing or for some works which needs clean state. What I want to say that all those commands are not only for local environment, but all those provisioning commands are it's in the one-to-one form opposite to the production staging environment, development environment. So this tool is used not only by developers, but the same tooling is also used by infrastructure guys and also by CI/CD processes, automatic provisioning and stuff like that. With this approach, you are able to remove the drift between the production environment and the local one. Another set of commands is with regards to vault. There is still some sensitive information which needs to be hidden from others and which are not yet meant to be committed. So because of this one, there is the vault. It's an Ansible vault, nothing special, which provides the way how to edit variables, provides the ways how to decrypt vault file or encrypt the vault file. And what we need just to maintain is the master password for each environment. And everything else sensitive with regards to environment is connected via vault and depends on the concrete access. Some people have access to some concrete files of the environment. So there is the production vault, development vault, and some of that. Everyone has limited access to it, only when he needs to something to get the access. The next thing which I want to mention is about the builders. So the first thing set of commands was about the provisioning, about the infrastructures, and the last one, but not less important, is about the builders. As was mentioned, the description like or how it looked in the case of the Spring Boot application. So there is information that where in the archive is in place for jar archive, FAT archive, and those builders are responsible to take the archives inputs from the compiling process, transform it in different form like the Docker images, Debian packages, stuff like that. And it's about the packaging of our software solution. Again, the CI/CD process uses the same set of the commands. So the build and deploy of application artifacts can be tested locally. There is again some initializations of the builder environments, and it depends on the concrete packaging. You are able to choose what you want to build, and that's it's all about the support command by our knowledge tool. So it's simple to write your own tool, even if it looks maybe for you maybe not so familiar. It's really just build technologies like the Shell.js. There's Arc tool for Node. There's the background virtual box provisioning and some of that. So it's only up to us what we want to do with this command, and we instantly adding additional command to our project according to requirements. And still, it's simple tool. It's simple utility on the top of the existing tool. It's quite simple to maintain it. As I mentioned before, it's not greenfield solution. So it's a really bad approach to build up new provisioning tooling and all those things. But this one is only mentioned to be a glue between the developers and the infrastructure teams. So thanks for attention, and thanks my colleagues for actively developing and improving this tool for our project. It was just a really brief description of this tool, brief description that we have choose the Alexa containers because of flexibility. And feel free to ask if you have any questions, or now or after that. Maybe if I will get enough questions, I will write a blog with more technical details for this approach. As this one is a really short presentation for more concrete technical details.
If you do have any questions, of course, you have the feedback link. Feel free to ask those. Obviously, you can get us on our various social medias as well. But brilliant. Thank you very much, Stano. That was a great talk. Lots of good content in there. And it will be hard to follow, I'm sure. So let's do just that. Okay, brilliant. Okay, well, like I say, that will be a hard act to follow. So I'm going to take you through a slightly different spin on things. This is going to be going concept to cloud, a CI/CD approach with Amazon Web Services, AWS. So a little bit about me. I'm Aaron Bourne. You heard from me a little bit earlier. Head of development here at Hotovo in the UK. And been doing this for well over 10 years now, doing front end, back end, ops, everything in between. So it's worth getting this out of the way from the title, mentioning things like CI/CD and AWS. This is going to be a talk about DevOps. DevOps is the core theme of this talk. And you might be sat there thinking, well, actually, I came here to learn about CI/CD. I want to know about Java. I want to know about AWS. Well, we'll cover that, but we're going to do it through a slightly different lens. And the reason for that is DevOps, when done right, it brings buckets and buckets of value. And not only just to you and your teams, but to the organization as well. So we'll do this in two parts. We'll go through some principles which really underpin DevOps. I mean, we have 20 minutes now. We don't have enough time to go through every single technique, but we can go through the underpinning principles. And in the second part, we'll go through a worked examples. This is a real life project that I had the pleasure of working on, and we'll dissect that with what we've learned. And hopefully there'll be some takeaways, things that you might want to try in your own projects. So, DevOps, the term's been floating around for a number of years now. It's been co-opted in marketing campaigns. You can buy DevOps tools. You can hire a DevOps person. But what does it actually mean? Well, this is one of my favorite tweets on the subject. And note this is from back in 2015, from the Reverend PHP CEO here. And I'll give you a couple of seconds just to read that. Now, if there's a little smirk across your face right now and you enjoyed that, good for you. But if you didn't, don't worry, because like every good joke, it's funnier when you explain it. So DevOps, it's not a job role and it's not a technology. It's something that we do. As software professionals, it's something that we do. And at its core, it's about bringing development, devs, and operations, ops, together. DevOps. Now, I get you might be thinking this is a little bit too sunshine and rainbows, and that's fine. I get that. I mean, at the end of the day, dev and ops, they're not too different, right? Well, let's break that down a little bit, because back in a traditional software company from days gone by, you have this concept of throw it over the wall. A team will do their bit and then throw it over the wall to the next team or person to deal with. Now, in this particular instance, we have two teams, two groups of people that we're going to focus on. And the first one, developers, dev. And they are responding to changes in the environment. They're developing features and they're wanting to do this fast, if not faster than humanly possible. On the other side, we've got ops. Now, they really value having stable, reliable systems. They want to keep the bad guys out and they want it with 9 nines of uptime. So on one hand, features moving very, very fast. On the other hand, really, really stable environments. Do they seem like they are in harmony to you? And actually what we have here in the traditional way of doing things is what we call an internal conflict. So two groups on the same side, but ultimately their goals are just a little bit too at loggerheads with each other. So what are the sort of things that we've seen in the past throughout history as a result of this internal conflict? Well, the first thing that we've seen a lot is long lead times. Things going from idea to out in the wild, but taking so much time. And if you think about it, you've got two groups of people and their goals are opposed to each other. They're going to make it difficult. There's going to be hoops to jump through. There's going to be red tape, and things are going to take time. Low team satisfaction. So we find that if you're set up to fail from the beginning, so if the feature that you're working on that needs to go into production in order to have any value to anybody isn't going to go out there for 9 months, you're not going to be too excited about it. And the same, if all what you're receiving is services to go into the environment and those services keep on falling over, again, it's not really the route to happiness. Low team productivity. At this point, it's probably no surprise, but if things is going to go out in 9 months' time and not tomorrow, next week, there's going to be a low urgency to want to do that. And additionally, if you don't feel enthused to do something, if your team does not feel enthused to deliver, again, there's not going to be a lot of productivity there. It can result in a toxic culture. Again, it's the us versus them situation. Draw a distinction between two groups with opposing goals, and it can be not the nicest place to be in. And we don't want that, not at all. It can be hard to win. So not only for yourself, I think we've kind of covered that here, if you're a member of either of these teams, not for your team necessarily, but for your organization. I mean, especially this day and age, you win by getting to market first, by getting the latest feature out, by getting the latest product out. And if you're not the first person, you're not going to win. And repeated mistakes. And this is a really, really important one. So put it this way, you're a developer, you've developed a feature and it's the best feature and you know that it is. And it goes through and 9 months later, 6 months later, it's in production, it's being used by users. But there's a bug hidden in that. It brings everything down. Now ops, they scrabble, they bring it back up again and everything settles down. But the developer, you haven't learned anything from that. There's been no route for you to get feedback, to learn. And I don't know about you, but I find it really difficult to know line for line what I developed 6 months ago. It's even harder for me to know what somebody else developed line for line 6 months ago. It's not you necessarily deploying your own code here. All of this can result in unhappy customers. I don't need to explain that one to you. That's obviously a very, very bad thing. But it's all fine, right? Of course not. Of course not. We can do better than this. We have done better than this. So we've gone through the traditional development operations, completely siloed teams, and we've heard about DevOps. We like DevOps. How do we get there? How do we get to the DevOps promised land? Well, there's 3 ways. And these aren't my 3 ways. These are 3 ways that are rooted in the manufacturing revolutions of the 80s. And in that time, they've gone over to the software world. They've been refined. And they've actually been put rather eloquently in the book, The Phoenix Project, a book that I've bought many copies of and given away many copies of. The content is so good. I do highly recommend this book. But what I'll do now is just give you a very, very high level of what those 3 ways and what they look like. The first way, systems thinking. Now, this all comes down to thinking of things from start to finish. So code that's written, services that are written, they only provide value when they're run by a human in production. They don't earn value when they're being written, when they're being thought about, when they're being deployed, but when they're actually used by a person. So doesn't it make sense for everybody involved to think about things going from start to finish, from it being used by an actual person? That's what systems thinking is all about. It's about work going only one way, and that is downstream. You may see, if you use a Kanban board, this is a visualization of this. Things move from left to right. Now, this also means don't pass junk downstream. So as a developer, it means not writing a service which you know might potentially fall over at some point. You know it's perhaps a little bit flaky, because that will get to the operations stage of the pipeline and it won't go any further. It will need to be fixed and it will gum up the works and things slow down, and you don't want that. You want to be fast, you want to be efficient, you want to be effective. Now, it also means not getting caught up in the little bubble. And what I mean by that is optimizing in your bubble, but to the detriment of everybody else. And an example of this is something like, I am in a dev team and we've decided that we're only going to package up our artifacts, our software, and we're only going to do that every 6 weeks because it takes a little bit of effort on our part, and it's easier if we do that and then we test it every 6 weeks. Hey, it works, but then operations have to pick that apart, perhaps, and then they have to deploy 6 weeks worth of work in one go. And thinking about it, wouldn't it be easier if we just drip fed features through, just dealt with little bits of work at a time? So think of the entire system, the first way. Now, the second way, this is all about creating, shortening, and amplifying feedback loops. Now, you might be thinking, what's a feedback loop? We know that work only goes one way, from left to right, goes downstream. But information can go upstream, and we want it to come upstream. We want to know how our service is running in production. We want to know what users think about it. We want to know what resources it's using. We want to know if there's a certain event I really, really care about. How often does that event happen? When does it happen? That's feedback. And the more information that you have, the better informed your decisions are, and the better everything is overall. The third way, and this is key as well. I mean, this is all about continued experimentation. Things get better, but you have to try them first. And do you know what? It might not go well 100% of the time, but you can learn from the failures because you've set everything up in a really, really safe way. You can do rollbacks if you need to. If you go too far, you can get back to a safe place. But you're always learning. Think Edison and the light bulb, right? Through continued experimentation as well, learn from mistakes, you will achieve mastery. Now, an example, we move on to part 2 of the talk. Now, it's a REST API in the cloud. It's a Java REST API. The cloud is AWS. It's, again, a project that I worked on. And now I'm not going to stand here and say, this is 100% the best DevOps solution out there. Everything was done right in this case. No, this is a practical project, a real-life project with real-life constraints. This is something practical, and hopefully you can take bits away from it as we've done here to try and implement. So here we go. Downstream's that way. That's the first way. So we'll start with developers. We know we're developing a REST API, and we know because the stack that we like to work in, and actually it's the right tool for the job in this particular instance, was Java. We use Java plus Spring Boot because we find Spring Boot really effective tool, great community, something that we like to use. So we have this. We know that AWS is where we're wanting to deploy it to, so that's a box on the right there. We need a central place to store code, so let's put a GitHub icon up there, use Git. We actually use the feature branching methodology, so everybody who works on a feature takes a feature branch, works on their independent branch, and then it gets merged in after review into the develop or master branch, depending on the flavor that you're choosing on that project. We need something, once we commit, to continuously integrate our code. So we want to do things like run tests. We want to be able to analyze our code. We want to be able to deploy our code. We'll put a circle CI icon there. For this particular project, and again, I hear you saying, well, actually, it's an executable, what you get out of Spring Boot. You can just execute it and run a Spring Boot application on a server somewhere. And you know what? That's a completely reasonable thing to do. But of course, and again, it's probably for another talk, but Docker is a really good solution as well. By wrapping up in our Java application in a Docker container, we get a single artifact with all our dependencies that we can then pass through our development stream. On top of that, we can then make use of things like our orchestration tools, the Kubernetes, the ECS, things like that. We can scale out easier. And there's a great community around it as well. But again, not for this talk. We chose Docker in this particular instance. That's what our artifact was, a Docker container. Now, we have a Docker container, and we know we want to get into AWS. Enter ops. So having, and bear in mind actually, ops working in the same team as dev, together, DevOps, having had a conversation, it was decided that actually the best way to approach this in this instance was to use an infrastructure as code solution. So CloudFormation in this case. Now we did consider Terraform, of course, and there are alternatives, but CloudFormation in this case. So the whole of what we wanted to run in AWS was coded up there and added alongside the actual application code in the same Git repository. So we actually used ECS in Amazon Web Services. We set an API gateway in front of it for security reasons. We wanted to use API keys, wanted to integrate it into authorizers, things like that. And we also use CloudWatch for our metrics gathering, logs, things like that. This is us putting it into the same repository. This is it being picked up by Circle CI or whatever CI tool that you're wanting to use. Docker push our built application into ECR, so the Docker repository that lives inside of AWS. Boto deploy to ECS. Now we use Boto, which of course is the Python library for interacting with AWS. Instead of the standard AWS CLI, it just allows that bit more complexity to be coded into the deployment process, but of course, all depends on your situation. There's the API gateway that I mentioned, and there is a CloudWatch box. So that is our downstream. That is work, including ops and application going downstream into production. So let's think about the second way, feedback. We actually get feedback straight away as developers working on our code by using tools like checkstyle, PMD, and find bugs. So they do static analysis on our code at the time that we write it in order to get immediate feedback. Perhaps we're not writing code to style. Perhaps we've inadvertently written code in such a way that is known to be an issue. That tells us straight away. Oh, this is, of course, in addition to unit tests. There's something similar that you can do on the CloudFormation side with validation, dry runs, things like that. So that happened there. Obviously, the tooling is not as robust as all of the stuff that we had set up on the development side, but we had that tooling for immediate feedback as well. Second stage along our journey, we get code review. So remember that Git branching methodology I mentioned earlier? So to get from your feature branch into your master or develop branch, another pair of eyes have got to look at it. And you get immediate feedback when they do. In this particular instance, we've got operations, perhaps looking at dev code and dev looking at operations code. Next step along, we get into our CI situation and we get immediate feedback when tests fail. There might be unit tests, there might be system tests. So once something's deployed, it might be some tests that run in an environment, perhaps test the environment's running. And of course, we get any feedback when the deployment fell for whatever reason. And again, we can go in, we can fix those straight away. We also, of course, CloudWatch, like I said, does metrics. So if a service goes down for whatever reason, we get feedback. We also get metrics capture at the CloudWatch level in production, so we can know when certain events happen, all of that in production. And just to throw into the mix, again, we're not sponsors or anything, but the tool that we use in this instance was Sentry. So if any exceptions or anything happened in production that perhaps we wouldn't have known of necessarily without trawling through a log or perhaps getting a weird metric back, Sentry will tell us straight away. So in summary, 3 ways. Focus on the performance of the entire system, not just your little bit, the entire system. Implement feedback loops. Be informed, make good decisions. It's the second way. Third way, try stuff, reflect on it. If it works, keep it. If it doesn't, throw it away, learn from the mistakes, try again, rinse and repeat. And they really are the basic principles that underpin DevOps. And there's hundreds and hundreds of tools in the toolbox, but you'll find that at its core. And of course, it's all about bringing 2 groups together, operations, dev. It's all about being excellent to each other. So that wraps it up for today. But what I will leave you with is this talk, I believe, will be available on the various different avenues. Here's my email address. If you are on a project which is in a similar position, you want to chat about it, you've got some feedback for this talk, perhaps you have a project coming up and you want to kind of run through perhaps how Hotovo can help you with that, let me know. And of course, we'll get back to you and can have a chat about that. Thank you very much for attending. I'll now pass over to questions. No, I don't feel pressured to. Like I say, you've got my email address, you'll get everything that you need. You get some social medias. So yeah, thank you very much. So that leads us on to our third talk, our grand finale of the evening. And that's Mr. Kaskak. So what I'll do now is I'll stop sharing my screen and pass over. Thank you very much.
Thank you, Aaron. This was really impressive, at least for me. Thanks for that. So I'll share my screen now. Okay, you should see my screen now. And this is going to be a bit different presentation. I don't have any slides, no memes, definitely. So this is all going to be hands-on. And I'd like to show you what are the options when we want to build, deploy, and configure Java applications in cloud, and more specifically on Kubernetes. I have two applications. These are really basic Hello World applications. One is in Spring, the other is in Micronaut, as I felt that Spring Boot being more dominant loses traction due to other frameworks and you guys on the blog. So I wanted to show you the different Java framework that is maybe more cloud native than Spring Boot, but of course this is debatable. So we have a basic application here. There's really nothing special about it. We have a single REST endpoint on the root path, and we're just going to display a property. So this property is a username. This would act as a way to demonstrate how we can configure Java applications in the cloud on Kubernetes. So first, like the most basic approach, how we want to build and deploy application on Kubernetes is to build Docker images via Docker file. So let's start with our demo. I have a little helper here. So normally we would just, let me switch to the Spring application. Normally we would build the application via build tool, either Maven or Gradle. So we're using Gradle here. We build the application. So the end artifact of that build is a jar file with this name. So if you look at the Docker file now, I can maybe zoom in. So we are using a base OpenJDK 15 to be on the cutting edge. And we're just copying the jar file. And the entry point is really just running Java jar in the application. So to build that, we'll use a Docker build command. It's running, sending context to the Docker daemon. And it's copying the jar file. Now we have the image ready. Now I'm going to use a very handy tool called Dive. If you don't know it, give it a try, which can analyze layers in the Docker file. So for those who don't know, the Docker images are composed of different layers. And you can imagine a layer as every entry in the Docker file, which changes the file system in the final image, is a different layer. So this way, if the previous layer doesn't change, the Docker doesn't have to build it again, it can cache it. So we're now trying to inspect our DevOps meetup image with the Spring tag. It's taking. taking a while, so let's give it a few more seconds. Well, in the meantime, maybe to show what we should see in the final REST API call is the Spring user property. Okay, so this is the dive tool, and we have 4 layers in that image. So this is the base image. This one's coming from the OpenJDK image, which installs Java. And this is our application. That green part here in the file tree represents the content of that layer. So the whole thing packaged as a jar file is a single layer. Now this has the disadvantage that if we change either the dependency or a resource or a class file, or basically a source file, we need to create, we need to build a new jar file. So it would come with a different hash and it can be cached as a Docker image separately. All right, so now if we want to deploy that to the Kubernetes, I have a local Kubernetes cluster via a tool called Minikube. And to deploy to the cluster, we're going to use Kubernetes YAML files. So these are basically descriptions of various Kubernetes objects. So we'll have a deployment. This will deploy a single replica of our application. This is the template for the pod that will be created. And this is important. So we'll be using that image for the pod. And we'll have a service that will expose our REST API via HTTP on port 8080. So let's go to the command line. This is the command to deploy the deployment file. I don't have a namespace, so I want to create a new namespace for this demo. So let's create a namespace. Okay, we have the namespace. Let's try again. Right, so now we have a pod, which is running our container with our application, and we have a service. Now to reach the service locally, I want to do the port forwarding as I don't have it exposed. So this is a cool tool from Kubernetes. I will expose, I'm sorry. I will port forward localhost 8080 to the service. Okay, now let's try the curl. Okay, it's not up yet. Takes a while. Not up yet. Thing is that the Minikube cluster is quite resource intensive, so my laptop can't keep up. No, nothing.
Check the pod.
Yeah, I can check the logs in the pod. So let's try do the on the fly troubleshooting. So we are going to check the logs of that pod. The application is up and running and it doesn't have a config map. Okay. This must be coming from my previous. Try. Should not be relying on that. I think I know what's going on. It's running and it just takes a while to spin up the service. So we have the response from our REST call, and it displays the property file, which is bundled in the application. All right, so now I'm going to show you a different way how we can package and build the image from with the Spring Boot application, and we're going to use something called a build pack. So build packs is relatively native technology for the cloud world, and if we look at our Gradle build file, there's nothing special. Only I have the boot build image defined, the image name defined, but everything's covered by the Spring Boot plugin. It already has a support, I think, from the version 2.3, supports build packs. So the Gradle has these tasks related to build packs. Now what this does is that it compiles, it builds the application and creates the image with build packs. So there's a lot of like concepts. I don't want to go too deep into build packs, but basically it detects that my application is a Java Spring Boot application. It detects that it can use these build packs to provide the layers for the final image, and it builds my image. So it does the detection, the build, and the release, which is in form of Docker image. And we're going to look at the content of the image with the dive tool once this finishes. Okay, it's done. So let's see how this differs from the previous basic image built with the Docker file. My laptop is spinning like crazy. So this is one downside of using local Kubernetes cluster with 12 cores, well, 12 threads, 6 core, 12 threads. That's the throttle, I guess. So maybe while we're waiting for that, I'm going to also enable configuration of the final application on Kubernetes. And for the configuration for the, oh, this is finished. So let's go back here and I'll continue afterwards. So we have a couple more layers. So these all are built via build packs. So this is, for example, let's take a look at this one. This is 162 megabytes. So this is the Java runtime, and our application is here. Let's collapse these. So this is our workspace. Now, it's worth noting that this is not a single Uber jar. It's split between the dependencies, resources, and source files. Well, compiled source files. So this is our application. But it's still worth noting this is a single layer. So we haven't configured the layers yet, or we won't, but there's an option to configure layers. So the build packs would create layers based on the content of our application. So there's many more. Now, if we want to configure our application in Kubernetes, we will use config maps. This is an object used in Kubernetes world to store properties for the files, environment variables, and things like that. So this time we're going to create the container based on our Spring build packs image, and we'll need a service account. And why we'll need that is because we are using Spring Cloud Starter Kubernetes library. So this is an integration option for the Spring Boot applications. And this will actually call the API, the Kubernetes API. And for that, we need to have a service account with some privileges for that. So we have a service account, so we need to create this first. I'm creating the service account. This is basically a role, what it can do, a role binding, and a role binding is basically a role assigned to a service account. So we have the service account, and now let's run the deployment. Okay, so we now have 2 pods. One is terminating, one is running. Let's give it a few more seconds. You can check the logs to see what happens there. Follow the logs. It hasn't started yet. We're waiting for this Spring Boot banner. What is quite interesting to see that the build packs also optimize Java process to fit the container environment. So it sets some memory allocation and memory limits based on the resources available to the container. Okay, and Tomcat's running. I'll restart the port for that to be sure. Okay, let's try our API call. Now, this comes from our config map. So this overrides the one bundled within the application. Cool. Let's move to the Micronaut version of our Hello World REST API. There's nothing special, really, just the different annotations. If you don't know Micronaut, it's mostly the same thing, but with different philosophy behind. So it doesn't use any bytecode generation or dynamic proxies or class loading magic. Instead, it uses annotation processing. So kind of a macro generating application. So when you run your application, there's no reflection at all. All is pre-compiled. And this is done by annotation processors that Java provides. So again, there's nothing special. We do have some configuration file here and a bootstrap. And we're going to straight away configure our application in the cloud, but this time via Kubernetes secrets. So secret is like a version for config maps with some sensitive data, like for passwords, storing keys, and things like that. So we're going to use secrets to configure our application. And for that, we need a bootstrap YAML file that's read by the Micronaut, so it knows where to look for the secrets. And before we deploy, we want to build the application. And there's another way how we can build the Docker image. And this time we're going to use a tool called Jib. Now, Jib is special in a way that it's only for Java applications. Yep. I need to go to the DevOps meetup Micronaut application. So I was saying that the Jib is a tool to build Java applications only. So it's building our file. Again, it takes the sources, the resources, the dependencies, it creates Docker image, and we can look at the image content again with the dive tool. Well, this is running. I'd like to show you the build, our Gradle build file. So we are using a plugin for the Gradle with chip, and the only configuration I have here is again the name of the final image. And since I want to use a distroless image, I'll explain that a bit later, we're falling back to the Java version 11 because higher versions are not yet supported for those official Google base images for distroless versions. Now this is still analyzing the image. And also Kubernetes comes with some integration with the Kubernetes in terms of extra library that we can include in our project. And this means that when the micronode application starts, it knows that it can detect the environment. So it knows it's running Kubernetes, and it can query the Kubernetes API or look for the secrets or understand the discovery of services based on based on Kubernetes rules. Okay, so this is the content of the JIP image. Now this is quite interesting. Since we're using distroless, it means that there's in the basic image there's not much. There's no package manager. There's no shell, so you can't even SSH to the box. This is really slim, 1.8 megabyte. This guy here is probably Java, 170 megabytes. Yeah, it's Java. And this is our application. And now, out of the box, we get 3 different layers for our application. One is for dependencies, the jar files. One is for the resources only, so configuration. And the last one is our source code compiled. Now, if I change only the source code, the previous layers don't change. They have the same hash. So the JIP build knows it can use the cached version. It doesn't have to do it again. So it only builds the last part. So this is important for the caching and for the speed of building those images. Okay, now we don't need a service account because we're going to create a secret that it's going to be mounted in the file system, in the container file system. So I'll create the secret. So the value will be micronode secret cube user. I created the secret. I don't need the service account. So this is the volume that the pod is using. This is the mount. So etc secrets. And this is the way how micronode applications knows that it can read the secrets from the secret. All right, so now let's try to apply that deployment. So it's a different service again and a different pod. Let's look at the logs. Okay, it's reading a bootstrap YAML file. So it understands that it's running in a Kubernetes environment. Okay, this doesn't look good. I think it's fine. This is just trying to read config mass, but we are not using any of those because we don't have the service account. We can probably ignore this one. Okay, let's try to create a port for that. And here it is. Right, so the question is around security. If we have the secret mounted on a file system in the container, and it's easily reachable by anyone that can somehow SSH into the container. But in this case, since we're using this role as image, that's not an option. So it's another layer of protection. And I guess that's everything I had for today. So thank you very much for the attention.
Well, cool. Do we have any questions for that presentation at all?
Yeah, there's a question about whether we use Lite4j at Hotovo. And to be honest, I haven't heard of it, so I don't know. we don't use it. No.
No, I can't say I've used it in my teams. It's not to say that we don't use it in some of the research work that takes place. Unfortunately, I'm not able to comment on that one. But perhaps something to look at in the future.
Okay, another question is, how is Spring Boot REST 8 application performing in production? Have you done any performance measurements of apps you've built? That's a really good question. So basically, what we have in production are not that intensive applications. They're more like for end user, like corporate end user with limited number of users. So we don't build it like in a non-blocking way that can handle more load and asynchronous processing. So yeah, that's answered the question.
Yeah, I suppose I'll build on that by saying that in terms of things, especially like CloudWatch, for example, CloudWatch metrics, if we have a long running process that perhaps you want to keep tabs on, then there's no reason why we can't use a timer and then emit that as a metric, then keep an eye on it, which has happened in the past. So it's, yeah, so to kind of build on what Misa was saying there, it's not like we're doing like the non-blocking kind of high performance web apps on every single case, but where we need to keep tabs on things, we do so with metrics, and that really depends on whatever solution looks like at that time. So there's another question that's come in here that says, how would you provision different configuration for different application environments?
Right, so if this is a question about Kubernetes, so normally you would have a different namespace, and you can use the same config map with the same name in a different namespace. That's the one way to do it. The other way is to use a different config map name. So you can change the config map name and just tell Spring Boot application to use a different config map or a secret.
That's good to me. I'm not seeing any further questions in the Q&A. However, what I will say, of course, is you can get in touch with us on any of our social medias, emails, anything like that. We'll be happy to answer any questions that you may have on the presentation. So what we'll do is we'll wrap it up there. Thank you for our presenters and our presentations. Thank you, everybody, for attending. Like I say, really do enjoy doing these. So hopefully we'll see you on the next one. If you do think up any questions, over the course of the next days, hours, please feel free to get in touch with us. Like I say, we love to have those conversations, so please do that. Other than that, do enjoy the rest of your days, evenings, and we will speak to you very, very soon. Thank you, everybody.
Thank you. Bye-bye.
Thank you. Goodbye.
Yeah, bye.